So basically, in this lecture, we are going to look at immunity. It is one of the um, chapter that you are going to get some questions from. So I'll just run through it. After that, you can make more research on it. Is that okay? Now, immunity is the ability of an organism to resist harmful microorganisms or toxin by neutralizing or eliminating them through specific or non-specific defense mechanism. Is that okay? Through either specific or non-specific defense mechanism. When you say you are immune to something, it means can resist that something. Is that okay? Immunity is the ability of an organism to resist harmful microorganisms or toxins by neutralizing. It's either you neutralize them or you remove them completely from your body. Is that okay? Now, types of immunity. Basically, there are two types of immunity. We have what we call the innate immunity, and then we have what we call the adaptive or acquired or specific immunity. The innate immunity is also called natural or non-specific immunity. Is that okay? The innate immunity is also called natural or non-specific. When something is innate, it means inborn. They born you with them. Is that okay? So that kind of immunity that is inborn is also natural or non-specific immunity. Is called innate immunity. Why do we say it's not specific? Now, it is not specific because it actually covers a wide spectrum of organism. Like it is not against a particular organism. For instance, when you are immune against, let's say, Ebola virus, or you are immune against yellow fever, or you see people going to take measles vaccine, those one is what specific to measles. But for the innate immunity, that one is for all pathogen or pathogenic organisms or any organism that might actually cause harm to the body. So it is not specific to a particular organism. It is innate, it is inborn. As they born you with that, you already have it. Is that okay? That one is innate immunity. Now, we say the innate immunity is present at birth and provides immediate defense. It is present at birth and it provides immediate defense. It is not specific, that means it acts against all pathogens in the same way. I have explained that. No memory, does not improve upon repeated exposure. This particular immunity does not have memory. Like if there are some kind of immunity which we will look at later, the acquired immunity. If you are already exposed to it, when that organism enter your body again, there are what we call memory cells that will tell your body immune system that, oh, this kind thing I don dey exposed to am before, this is what we did to it. Are you getting it now? Exactly. But for innate immunity, they don't have any memory. So continuous exposure, you will just be causing more kind of like more like it does not improve upon repeated exposure. Let me just put it like that. Are you getting it? Your body no dey remember am say this kind thing don happen to you before. So it does not have any memory. Now, examples of innate immunity. You have physical barrier like your skin. Your skin is an example of innate immunity. You have your skin as part of your body. Do you know that the skin protects you from various infection? That's the reason why when you have a wound, your skin is open. You can easily be infected through that wound. Are you getting? So skin is a part of the innate immunity. It's a physical barrier. Then we have mucous membrane, the ones in your nose. All those ones are part of the innate immunity. Then we have chemical barriers. These ones they are classified under physical barrier. Then we have chemical barriers like enzymes in saliva. Then the stomach acid. Those ones they also help to kill organisms. Is that okay? Then cells like phagocytes, neutrophil, macrophages, natural killer cells. All these ones they are part of what? Innate immunity. As they born you, you already have them in you. Then inflammation and fever. You discover that when you are sick, what will happen? Your body defense mechanism will cause you to what? To be having pains and will cause you to be having high temperature. Some persons will be like, why am I having it? Why do we say that hot temperature, like your body go dey hot, you go dey get fever? Are you getting it? That your body getting hot prevents the spread of that pathogen. Is the way your body works. So whenever you are sick, and your body knows say, harmful substance don enter your body, The next thing you go do na fever, boom, your body temperature don start to dey hot. That is why whenever you are sick, you get hot. That hotness is an immune response that your body naturally gives. Are you getting it? In order to limit the spread of what? Pathogens. Then the complement system. The complement system is more like a system where, let us say, a particular antigen enter your body. Let us say something enter your body, foreign organism enter your body. The complement system will be activated. How will it work? That foreign substance will enter your body. There is what we call opsonization, whereby something will mark, they will just mark that harmful substance, that foreign substance. It will be like flag, red flag. Are you getting it? Flag it like they will, it just be like the way this thing be. Let us assume this thing are foreign something to your body. What will happen is that it will be opsonized. Opsonized with, let's say, a red something like this. Like they go mark am around. Say, so whenever the body see this red something, wetin go happen be say there are macrophages, there are phagocytes, there are natural killer cells that will now come and what? And kill this particular cell. So let us assume that this is a harmful substance. Opsonization is like you marking that substance to know, say, so that it will be easy to identify, say, this thing when we say this present day here is not part of also. Let us kill it. Are you getting it now? That process of marking it is what we call opsonization. Then after opsonization, what would happen? This whole substance here will be engulfed and broken down. Are you getting it? So complement system is, it enhances phagocytosis and cell lysis. And the component of the complement system, you have opsonization. I wish I could actually explain this thing from beginning where you understand all these things. But I think we did that in 400 level pharmacy. So as time progresses, you guys are going to do it also. Do you understand? So that is that with opsonization. Opsonization is more like you, everybody when they the place, we know them. So when foreign person enter, wetin go happen? We just mark, the body go mark that person. Not be say na im dey kill am o. That opsonization, not be say na that thing when they opsonize and na im dey kill am. You go just mark am say this person no be part of us o. If you like, enter the village. As they don know say soldiers go come say, hey, you no be part of us, kill am throway. Are you getting it now? It's more like the what happened in the Bible. What happened in the Bible? God tell angel, abi? Angel also, abi, he tell the people say, make they kill animals. Then use the blood to rub front of their houses. That when the angel of death come, he will pass them by. And anybody when they don't see that this thing for their front, wetin go happen? They will buy you. The same thing is what is happening here. The opsonization and that mark, that blood when they put, are you getting it? But for this case now, once they mark that blood, it means say they no go buy you. But for this case, once they mark you, it means say they go do anything, they go buy you. Are you getting it now? So that is opsonization and the complement system generally. So that is that for innate immunity. We say innate immunity is that kind of immunity that is present at birth. It is not specific. It acts against all pathogens in the same way. It's not for a particular organism, and there's no memory. That means you know they remember body, the body not they remember say this kind of thing don't enter your body before. Are you getting it? That part of the immune system does not keep record of anything that has happened before. Example, a physical barrier, chemical barrier, cell like phagocytes, neutrophils, macrophages, natural killer cell, inflammation and fever, which we said they limit pathogen spread, and complement system that enhance phagocytosis and cell lysis. Is that okay? Exactly. Now, adaptive immunity. Now, the adaptive immunity is also called acquired. It is not from birth. You go acquire am. Now, somebody gave us a story, a lecturer gave us a story that a particular person actually came from America, and then when he came from America, he discovered that there were so many mosquitoes here in America, in Nigeria, and he decided to seal everywhere in his house with mosquito, what is it called? With mosquito nets, and both treated nets and everywhere, so that single mosquito no go touch his children. Okay, now at some point, somehow, One of the pikin contracted malaria. Normal malaria when be say they treat you, people for here, everybody dey well. Those children almost died of malaria. Why? Because they've not been exposed to it before. Are you getting it? So they almost died of the malaria. So my lecturer was like, he was not telling the man that what you should do is allow mosquito bite these children. After you don't do am, after it don't happen once, twice, your body will get adapted to it. Are you getting it? And when your body get adapted to it, as time goes on, you now acquire immunity against malaria. There are some of you that malaria will bite, mosquito go bite. Especially those of you that have AS. Mosquito go bite you. Year to year, you know they sick. Not only headache, you take paracetamol, you are fine. When there are some persons, especially those that are they are always protecting, if they can't come somewhere where mosquito they bite them, once mosquito bite them overnight, they don't sick. Do you get the idea now? Same thing applicable with adaptive immunity. Adaptive immunity or acquired immunity is as a result of you being exposed to that thing before. And as you are being exposed, you are getting strong. Your body is building that defense against it. It's like they flog you. You don't flog you reach one stage. Pikin not come dey pain you again because your body don dey used to am. Are you getting it now? Same thing applicable to this. Are you getting it? So adaptive immunity or acquire or specific immunity develop after exposure to antigens. That means after your body don't dey exposed to this foreign organism and it targets particular pathogens. It is specific. It has memory, stronger response on subsequent exposure. The more you don dey exposed, the more your body don dey used to am. So it has memory. Because you just be like, you don do am before, dem flog you before, e happen before abi, okay. Mosquito don bite you before, so wetin you dey fear for? Are you getting it now? It has memory of like recognizing that this thing has happened before. So as time goes on, you go don dey strong. Are you getting it? Now, stronger exposure or subsequent exposure slower to develop initially. Now, component. What are the components of the adaptive immunity? You have lymphocyte, like B cells and T cells. These are the lymphocytes. Are you getting it? Then B cells, they produce antibodies and they are component of humoral immunity. So when you hear of humoral immunity, know that you're talking about B cells and they produce what? Antibodies. Is that okay? T cells, they destroy infected cell or assist other immune cell, which is cell-mediated immunity. Is that okay? Then memory cells provide long-term immunity. So these are the three components of four components of adaptive immunity. We have the lymphocyte, we have the B lymphocyte and the T lymphocyte. The B lymphocyte are the one that produce antibody, which is humoral immunity. So when you hear B cells, humoral immunity has to do with what? The B cell. T cells, they destroy infected cell or assist other immune cells like cell-mediated immunity. And then memory cell, they provide long-term immunity. Now this one they tell you say, oh, this did not happen before. Are you getting it? So that is that. Now, types of acquired immunity. Acquired immunity can be active or passive. Now, you could be active and natural or active and artificial. It could also be passive and natural and passive and artificial. Now, let us look at active. Active na the one be say e dey happen. For instance, natural active is a situation like when you already had measles before, you're already exposed to measles naturally, and then you are recovering from it. That one is natural active because the measles occurred naturally. Are you getting it? Then now, before you get the measles, if they vaccinate you, let's say there's vaccination, they give you vaccine before getting the measles so that you will not have measles. Like they introduce live vaccine into your body. Because this vaccine, there are organisms that are like, they are toxic, they are not toxic, but they are like microorganism too. But this one, they are not pathogenic. They know they cause disease. Are you getting it? So what they will do is, before you start having the measles, they will first of all like inject something that looks like that measles into your body. Are you getting it? So your body now will not get used to it in such a way that when the main measles enter, you're like, we already dey used to you before. You don't come here before. Whereas the one when we say they inject put na the one when we say e no go cause you problem. That is the process of vaccination. Let me explain. Vaccination just be like, okay, you get two person, one dey cause disease. We get two type of measles. One dey cause disease, the other one no dey cause disease. It's not pathogenic. They are both organism. The organism must be made not to be toxic. Are you getting it now? There's what we call attenuation. The organism has been attenuated. It's not causing any harm, but that is the organism. So what they do in vaccination is they will give you this organism wey no dey cause disease as a foreign organism in your body. So your body now go come build defense. You will be exposed to it. Do you understand? Like they will inject you with this one wey no go cause organism. So you gonna be like say, na this one you don dey build defense against am. So when the main one wey dey cause organism come, because their action, the way both of them act is almost the same thing. So when the one wey carry the disease come, they'll be like, you don already dey here before. So we are going to fight you. Are you getting it now? We go fight you. Because as time goes on, you are building defense against it on continuous what? Exposure. So when the one that has the disease immediately come, all this one go do wetin? Otilo, they don move am comot. Why? Because this one don come for the first time, they fight am. Come again, which are via what is it called? Via immunization and via vaccination. You give the person the vaccine, he fight am. He come again, he fight am. So the body is already gaining momentum, strength, in such a way that when the main one come, the body don already dey used to you. So as you come like this, otilo, they move, comot. Are you getting it now? So that is just how vaccine work and the process of vaccination generally. Two things dey. One na the one be say e no get the disease, na im be the vaccine. Na the organism na wetin dey cause the problem, but e no dey cause the disease. We just make am, we don reduce am. E no get that power again to cause the disease, but the way it works and everything still the same. So when the body, you don inject am for the body, the immune system will be activated to fight against it. After another exposure, the immune system is activated to fight against it in such a way that when the main one now, you are now infected with the main one, your body is already what? Like trained to fight against it. Are you getting it? Which will now kill that organism. So that one is active artificial. Now you, they actually cause that one. Example is MMRO vaccine. MMRO is mumps, measles, and rubella. They are vaccines that are actually given to children. Then passive immunity, type of acquired immunity, you have passive. Of course, passive, maternal antibodies. That one, you have natural maternal antibody, e.g. via placenta or breast milk. There are some antibodies inside your mother that when you suck her breast, what will happen? You get them into your body, and as time progresses, your body will start gaining momentum against them, like ability to fight them as time progresses, such a way that when you are exposed to those organisms later, they will not like hold you down. Why? Because the body is already built to fight them. Then antibody transfer, like anti-serum or immunoglobulin, all those ones, like you can actually inject this one. Are you getting it? This antibody transfer, more like injecting this anti-serum or immunoglobulin into your body. So that one is passive artificial. This one is what? Active. So you should be able to distinguish between both of them. Now, the question is, which of the following best describe passive immunity? Immunity developed through vaccination. We say vaccination is what? Artificial active. So that is not the answer. Immunity passed from mother to child through breast milk. That one is passive immunity. You don't know how it happens. Are you getting it? It just happens via, maybe as they take, normally breast milk na normal thing. So through the process of breast milk, you don't need any extra effort. That is why it is passive. Through breastfeeding, the child is gaining that immunity. Then immunity developed after recovering from a disease. This one is active. This one is active, and this B here is passive. So we say passive immunity occur when antibodies are transferred from one individual to another, such as from mother to child through breast milk, like IgA antibodies. IgA means immunoglobulin A antibodies. All right. Now, question two: what is the main characteristic that distinguish innate immunity from adaptive immunity? Innate is inborn, adaptive. Now, memory of previous infection. We are told that innate immunity does not have memory, but adaptive immunity has memory. But that is not the major thing. Use of B and T lymphocyte, that is not the major thing. Specificity to antigen. Then D, rapid non-specific response. Innate immunity is the first line of defense and responds quickly and not specifically to pathogens, unlike adaptive immunity, which is antigen specific and slower to act. Are you getting it? The adaptive is slow to act, but the innate is very rapid and it is what? Non-specific, which is option D. What you make around that distinguishes innate immunity. So you are looking at characteristics of innate immunity. Innate immunity does not have memory of previous, no. The use of beta, it does not use the specific, no. It is because of the rapid non-specific response. That is the characteristics of what? Innate immunity. Now, the next one. Which of the following is not a component of the innate immune system? Skin, complement proteins, memory B cells, and natural killer cells. We say memory B cell is what? Active, which are the B lymphocytes. They are part of the adaptive immunity responsible for long-term immunity after infection or vaccination. All right. The function of antibody in the immune system include all except neutralizing of toxin, direct killing of pathogen, opsonization for phagocytosis, activation of the complement system. Now, antibodies does not kill pathogen directly. They don't. What they do is either they neutralize. Opsonization, you know what opsonization is now for phagocytosis. Opsonization means marking them for destruction. Are you getting it? Then activation of the complement system, of course, but they don't kill the pathogens directly. Antibody not dey kill directly. Their own na just to come mark you so that when the killer cells, the natural killer cells, when you see them, they will just, when they see you, they just buy you. Now, antibodies themselves do not kill pathogen directly. They tag them for destruction by other immune cells or activate the complement system. A child receives immunoglobulin after exposure to hepatitis A. You receive immunoglobulin after exposure. That means you don already dey exposed before they give you. What type of immunity is this? This is artificial passive. See it here. We say artificial passive is transfer of immunoglobulin. That is when you have already been exposed. Artificial active is before exposure. Are you getting it? Before what? Exposure. This one is after exposure. So you should know the difference. Now, that is that. Which immunoglobulin is primarily transferred from mother to fetus through the placenta? Through the placenta, the only class of antibody that crosses the placenta is IgG, immunoglobulin G. Is the only class of antibody that crosses the placenta. You know, the placenta is like a filter. It allows some things to go through it, which we call the placenta barrier, and allow some things not to go through it. Is that okay? So that is that. What is the primary role of helper T cells? Now, the helper T cells, they don't kill antibody directly. They activate other immune cells. That is why you call them helper T cells or the CD4 cells. They activate other immune system. And these ones are the ones that are destroyed by HIV virus. So when HIV virus destroys this one, they will not be able to activate other immune response, and those organisms will keep on eating deep into your body. So helper T cells continue the immune response by activating B cells, which is humora, immunoglobulin, to produce antibodies. Are you getting it? And cytotoxic T cells to kill infected cells. They don't kill directly. They only coordinate immune response by activating the B cell to produce these antibodies and cytotoxic T cells to kill infected cells. Now, which of the following is an example of artificial active immunity? artificial and active. Receiving tetanus antitoxin, that is not true. Now, getting the hepatitis B vaccine. Vaccination is an example of artificial active immunity. Vaccination is an example of that. Which organ is the site of T cell maturation? T cell maturation is in the thymus. While B cell maturation is where? T cell in the thymus, B cell is where? Which of the organ do you think B cell? Bone marrow, liver, and the correct answer is bone marrow. For B cell maturation, is bone marrow, B cell. White T cell is the thymus. Are you getting it now? So that is that. What distinguishes active immunity from passive immunity? What is different? Duration of effect only. Only active immunity involve antibodies. Active immunity involves memory cell formation. Active immunity involves memory cell. We say memory cells, they are like cells that keep memory of what is happening. So offering a long-term protection. So even if 4 years to come, they don't even put you injection, you go keep am. Measles. Say we don't dey you, we don't see this man before. We kill at that time. Are you getting it? So immediately measles catch you, maybe even 3 years after or 2 years after, that active immunity will keep that memory at the back of your mind. So then when they just see measles, they know say seeing measles na kill, we go kill am. Are you getting it? Exactly. Without the measles having any effect on your body. So they have memory cell. That is everything about immunity you should know. Thank you very much for your time. We'll see you in the next one.